Assalamualaikum. So my name is lab3 and right now I'm gonna present to you my lab 3, which is about the POS controller. So basically in the lab 3 we do the hub application, which is we run hub reactive flow mode application. This is the command. So this hub already successfully loaded by the POS, as you can see in this, and then the custom controller application is running. And then the POX is ready to receive connection from the open flow switches, and the Python, because we are using the Python 3.5, so it's giving the warning, but it can be ignored for this lab since the application started successfully. So this is the code from the hub reactive flow mode. So basically in this code, it said that when a packet arrives at switch 1 and no flow will exist for the packet, the switch will send the packet message to the pulse, and then the controller will create a flow mode rule. A rule tells the switch to flood the packet to all of the port. The rule is then installed on the switch. So basically about this code. And then after we successfully run the rule, so we create the topology to test the rule. And then we create the topology by using the MAC address, and then the topology have a single switch but 4 hosts, and then the controller we specify as remote. And it said that the controller address is on the loopback address, and then the port number is 6633, and then we have 4 hosts, and each of the hosts have link to the S1, and then it successfully connect between switch and the host. This is example of the topology. So basically 4 hosts connected to the S1, and the S1 will listening to the POS controller. And then we test the connectivity between the hosts. So H1 send the packet to the H4. So it will send the packet successfully. So basically the switch allow packet flow between its hosts, and then we check the flow of the entry table. So we can see the number of packet is 14 packet match this flow rule, and then the total byte is 1148, and every matching packet is broadcast to all other switch port. And then for the next is the running hub reactive packet out. So we already run it, and then we can see the custom POS hub reactive packet out application was started successfully, and then the POS controller is running and ready, and the switch 1 successfully connected to the POS controller, as you can see. Open flow of 01 is connected. So in short, the POS controller and the hub reactive packet out application are running successfully, and switch S1 is connected to the controller. The controller will handle packet using packet out message without installing flow rule on the switch. So we're creating the topology, and then we test the connectivity of the host in the topology. And then we move to the switch application flow. So this is the code in the switch application efficient.py. So basically what inside the code is it's create MAC address table to learn which host is connected to the switch port, and then it's learn the source MAC address and store its port, and then it check whether the destination MAC address is already known, and if destination is unknown, flood the packet to all port. When destination is known, it will install a flow rule in the switch, and future packets are forwarded directly by the switch without contacting the controller. And then we have the idle rule timeout, which is 10 rule. The rule we move after 10 seconds of inactivity. and 30 will remove after 30 seconds regardless of activity. And then when the destination is unknown, the controller send the packet back to the switch, and switch flag the packet to find the destination of the host. Basically, when the packet arrive to the switch, and then they have no entry of the packet, entry table information of the packet. So basically the switch will send the packet to all of the switch, to all of its hosts to find its destination host. So we run the application rule, and then we creating the topology, and then we test the connectivity, and then we test the switch behavior. We test the switch behavior by using the adds term. So as you can see, when #1 ping to the #4 is successfully ping. So basically they have IP table that apply, and then the information of the IP table that match from the packet of #1 and the destination of #4. So for the lab 3, that's all for me.